So in the video today, we are going to talk about arcs and chords and central angles. So our objectives are that you can differentiate between minor and major arcs and find minor minor arcs and determine their degrees, and to understand relationships between central angles and arcs. Really, we want to find arcs and find their measures of degrees in degrees. Okay, so our first blank in our notes here is a central angle is an angle whose vertex is the center of the circle. So you see over here where we have angle A, B, C, and its vertex is at the center of the circle there, B. This is what we call a central angle, ABC. Then we have an arc. Is an unbroken part of the circle consisting of 2 points called the endpoints and all the points in the circle between them. So again, this is our second blank in the notes, arc. And this is our arc right here, AC. Okay, so that's an arc, AC. And then we also have another, that's what we would call a minor arc. Okay, that's because it is the shortest distance between 2 points. Now, if we had another point out here, like maybe D, and we're going to talk about that here, then we would call this other arc over here ADC. Okay, how many degrees are in a circle? Hopefully all of y'all know that. That is 360 degrees. Okay, so these are our 3 blanks, or our 2 blanks on the paper, and then this is a question, and you should write the answer there. Okay, so now a minor arc is an arc whose points are on or in the interior of a central angle. Okay, so the measure of a minor arc is equal to the measure of its central angle. So let's just say, for the sake of discussion, that this angle right here in the center is 80 degrees. Okay, so if this angle's 80 degrees right there, then that means this arc right here is also 80 degrees. Okay, now a major arc is an arc, let me scroll this up, whose points are on or in the exterior of a central angle. Okay, so basically here, now we have this major arc, ADC. Okay, so what we can do to find that is we could have subtracted the 80 that we had here from the whole circle. So we could have done 360 minus 80, and that would have given us 280 degrees for that major arc ADC. And major arcs are typically named with 3 letters. Okay. Okay, so then if the endpoints of an arc lie on the diameter, then the arc is a semicircle. Okay, so here what you need to know is that half a circle, if we divide 360 by 2, then that's 180, right? So this arc right here, EFG is 180, right? Because it's half the circle. Okay? All right. Given 2 points on a circle, the minor arc is the shortest arc linking them. So the major arc is the longest arc linking them, okay? So minor arcs may be named by 2 points. Major arcs and semicircles must be named by 3 points, okay? Very, very important point, okay? So we're going to find KLF. So angle, arc KLF, and this should have an arc symbol over it. I'm not sure why it doesn't. The measure of arc KLF is equal to 360 minus the measure. So we're looking for KLF. So let's find KLF. Okay, KLF. So that's this arc right here, guys. KLF. It's that arc, right? Okay. So to find that arc, what we could do is we could find the measure of what isn't that arc, and then figure out what the rest of it is. But in this case, there's a couple ways we could do it. Okay, so we could find what this is right here, right? This piece of the pie. Okay, now notice these are all in percents, right? So if we add up all those percents, we should get 100%. What we're going to do, however, is we're going to turn this into angle measures, because it's actually asking us for an arc, and an arc is an angle, is a measure in degrees. Okay, so what we're going to do first is we're going to add up these 3 numbers, the 20, the 8, and the 17. So that's going to give us 35%, right? Okay, now to find what angle that arc is, we're going to take 35%, we're going to divide it by 100, and that would give us 0.35, okay? So when we do that, then we're going to multiply that by our 360. So notice here it says find the measure of KJF. KJF is our blue angle over there, okay? So we're going to multiply that 0.35 times 360 because we want to know how many degrees is 0.35% of the circle, okay? So once we do that, we get 126 degrees, okay? So then we're going to subtract that 136 from 360, or 126 from 360, because that's what's going to give us what we're actually looking for, which is our red arc, okay? Because remember, our arc equals the angle here, because arcs equals central angles, okay? So we're going to subtract 126 from 360, and that gives us 234. Now there is another way to do this. Notice we have the 65% right there. So we could have done 360 times 0.65, right? And if you do that in your calculator right now, you will see that again, that's 234 degrees. Okay? All right, so let's see if you guys can do these next two now. The first one says find the measure of FMC. So let's see if we can figure out where FMC, angle FMC is. Okay, so FMC, so F is here, M is there, and C is there. So we're looking for the angle FMC. Okay, so it looks to me like we have three percentages here. We got the pop, the country, and the R&B. Okay, so what we want to do is turn those into decimals. Okay, and we're going to add them together. So we're going to add 0.09 plus 0.1 plus 0.11. Now, if you don't know how to do that, you're going to divide 9 by 100, 10 by 100, 11 by 100. Or you move the decimal place 2 places to the left, okay? So when we add those three together, we get 30.3. And then to find the angle measure, we have to multiply that by 360 because that's the measure of the whole circle, okay? So we're going to multiply this by 360, 0.3 times 360. And that's going to give us 108. Okay. Now, arcs are similar, so you're going to do these similarly to what we did the last one, only the difference now is it's actually the arc. So we're going to have to find the center angle by looking at the arc. So we got AHB. So we're going from A up here over to H and then all the way over here to B. Okay, so what are we talking about? Well, look at that. Isn't that 75% of the pie? So I think you guys could add up other jazz, classic, pop, country, R&B, and rap, or you could realize that you got 25% here, right? So that would be 100 minus 25 is 75. So we could do 0.75 times 360. And that would be equal to 270, right? Okay, you guys see that? All right, our last one. Go ahead and do this. Come back to me when you're done. EMD. So we got E here, M is there, and D is right there. Okay, so we're just talking about one little segment of the pie this time, right? So this is 0.1, and again, we're looking for the angle. So 0.1 times 360 is going to be equal to 36 degrees, okay? If you have any questions, ask now, okay? All right, so the next one is, first, a vocab term. Adjacent arcs are arcs in the same circle that intersect at exactly one point. So notice here that we have arc RS, and it connects to arc ST by S, right? So those are two arcs that are adjacent to each other. RS and ST are adjacent arcs. So that leads us into the arc addition postulate. So basically it says the measure of arc formed by two adjacent arcs is the sum of the measures of the two arcs. So let's just say that this was 40 degrees and this was 20 degrees, okay? And so to get arc ABC, we would add 40 plus 20, and that would be equal to 60 degrees. Does everybody see that? So that is the arc addition postulate, okay? Now, using the arc addition postulate, we're going to find BD. So BD is right here, BD. Okay, so there's a couple things I want to talk to y'all about here. So I notice that BC should be the same as AE. Do you guys see that? So look right here. We have a diameter there, and we have a diameter here. And aren't vertical angles congruent? Yes, they are. So we know that this angle and this angle are congruent. So I can say that this is 97.4 degrees as well. Okay. Now, there's something else that I noticed. We have a diameter. See that BE diameter? So if I was to add up all three of these parts, they should equal 180, shouldn't they? So that's exactly what we're going to do to find what CFD is. CFD, let me show you where CFD is. CFD, so if we want to find this part right here, that arc part, or that angle, then we have to add up the 52 plus the 97.4 and then subtract those from 180. Can everybody see that? Okay, when we do that, we get this up here was, I can't read my own handwriting, y'all, that's bad. 149.4. So we're going to subtract 149.4 from 180. And we get 30.6. Now, remember, this angle right here is equal to that arc because it's a central angle. So that means if angle CFD is 30.6, then the arc has to be 30.6. Okay? Okay, next we're looking for arc BD. Okay, so with arc BD, I'm going to erase some of this colors out here. I'm going to erase this right here. So now we're looking for arc BD. So we're looking for this arc BD right there, right? So notice the arc BD should be equal to angle BFD. Does everybody see that? Or we can just add those two arcs together. So this arc right here is 97.4 and this arc right here was 30.6. So can't we just add those two arcs together to get the arc BD? You got it, right. So we're going to add 97.4 because that was arc BC, and we're going to add to it arc CD, which was 30.6. When we add those two together, we get 128 degrees. Okay? All right, now let's see if you guys can do it. Okay, so go ahead and pause the video. Let's see if you can figure out what the measure of arc JKL is. JKL, so that's this arc out here. That's the first arc you're finding, which means you're going to have to find angle JPK and angle KPL, right? And then you're going to find LJN. Okay, after that, you're going to find LJN. Okay? All right, so go ahead. Pause the video, see if you guys can do it. All right, so hopefully you guys noticed that if we've got some vertical angles again here. See this? This is a diameter, sorry, and this is a diameter. So that means if this over here is 25, these arcs are congruent, right? So this is also 25, right? Okay. So then I notice again that we have the diameter JM. Again, we're talking about right here, this diameter right here, JM, right? So that means all of this above has to be 180 degrees, right? So what I'm going to do is I'm going to add this 25 and this 40. 25 plus 40, that equals 65, right? And we're going to subtract that from 180 because that's what half the circle is. So we're going to do 180 minus 65. That's going to be equal to 115 degrees, right? So now we know that this right here is 115, okay? Now what we're looking for is JKL, right? JKL, so our red arc up there. So don't we have to add together the 115 plus the 25? We do. So when we add those together, we get 140 degrees. Does everybody see it? Okay, the next one is LJN. LJN. Now there's a couple ways we could do this one. We could add up the 115, the 25, and the 20. Oh, we don't know what that arc is down there, right? So this one might be easier just to subtract this right here, that angle from the whole thing, 360, right? So notice that these two added together are 65, right? So couldn't we go 360 minus 65? Isn't that going to give us 295? Okay. Now, what's the other thing we could do? We could find this angle right here, right? So doing the same thing we did before. So this time, notice right there, we got half the circle. So we could do 180 minus 25. When we do 180 minus 25, that would be 155? 155, right? So, again, the other way to do this would be to add 115, this one right here, plus 25, plus 155. So that's going to be 140 plus 155, so that's also 295. So once again, there's more than one way to do these problems, guys. And it's good actually to do it twice, because then you can double check your answer. All right, so here's the last one. The last new concepts for today. How about that? Circle or congruent circles. Congruent arcs are two arcs that have the same measure. So again, if we were to say that these two angles were 60 degrees and 60 degrees, then obviously that arc right there is 60 degrees and this arc right here is 60 degrees, okay? So if the angles are congruent, the arcs are congruent. Now that is going to lead us to one more statement, which is that the corresponding chords are congruent. So congruent central angles have congruent chords. So notice here, if we had up here drawn some chords, UV and ST, then these chords would have also been congruent, okay? So here we have the two central angles, angle EAD and angle BAC are congruent. So that means their corresponding chords, DE and BC, are congruent. So we can say that these angles are these chords are congruent because the angles are congruent. Also down here, if we have congruent chords, then we can say that the arcs that correspond to them are congruent. So here again, if we have the congruent chords, then we can say that the corresponding arcs are congruent. So we can say that DE and BC, those arcs, are congruent, okay? Then obviously the third conclusion would be that congruent arcs have congruent central angles, okay? So down here, if we said that these two arcs were congruent, arc ED and arc BC were congruent, then that would allow us to say that angle DAE, this angle right here, is congruent with angle BAC, okay? So what I like to say is that congruent arcs are equal to congruent central angles, are congruent to corresponding chords, okay? So what you need to know is if you can see that these map to one another here, then they are going to be congruent. The arcs, the angles, and the chords. All right, so in example 3, it says applying the congruent angles, arcs, and chords. So TV, it says here, TV, that arc is congruent with arc WS. So what does that tell us about the measure of arc WS? So here, it's asking us for this arc, and don't we know that this arc is congruent to that arc? We do, okay? So what we're going to say is arc TV is going to be congruent to arc WS, right? Whoops, let's make that an arc symbol. Okay? So if that's true, then that means we can put those measures equal to each other, right? So we can say 9n minus 11 equals 7n plus 11, okay? So I'm going to add 11 to both sides. So now that's gone, right? And this is now 22 over here. And I'm going to subtract 7n from both sides. So now that's gone, and that's going to give me 9 minus 7 is 2. So that's 2n. Then we're going to divide both sides by 2. Okay, so that means n is going to be equal to 11. Now, it didn't ask us for n, it asked us for ws. So now we have to plug back in that n. So ws, the arc, is going to be equal to 7 times 11 plus 11. That's 77 plus 11. That's going to be equal to 88. Now, what I know is that these two arcs should equal each other, so a great way to check this is to plug that n back into TV as well. So to check it, we're going to put it back into arc TV as well. So that's going to be 9 times 11, that's 99, minus 11. 99 minus 11 is also 88. So we have just checked our answer to verify that it is indeed correct, and it is. So make sure that you pay attention to that. And as always, one of your answer choices will probably be 11. That's not the answer because it asked us to find the measure of arc WS. Okay? So let's see if you can do this, check it out, and then come back to me when you're done. Okay? So here again, we have that this time we have that the two chords are congruent, so that tells us once again that our arcs are congruent. So we know that arc CD is congruent with arc EF, right? So that's how we're going to do it. Let me give us a little more space to work with down here. So arc CD is congruent to arc EF, right? And it's asking us to find arc CD. So once again, we're going to say 25y is equal to 30y minus 20, okay? So in this case, I'm going to subtract the 30y from both sides. That's going to give me negative 5y is equal to negative 20. Then I'm going to divide both sides by negative 5. Remember, when you divide a negative by a negative, it gives you a positive. So y is equal to 4, okay? So here again, I'm going to plug that in to finding the measure of arc CD, right? So that's going to be equal to 25 times 4. Well, that's 100, right? Okay. Now, how do I check this? We plug it back in the other measure as well. So to check it, we're going to find the measure of angle of arc EF, right? Be great if I could write today, but I can't, obviously. So arc EF, it should be the same, right? So we're going to go 30 times 4. That's 120 minus 20. What's 120 minus 20? That's equal to 100, right? So this is 100 degrees. And so if these measures are the same here and here, then we know that our answer is correct. So again, on a quiz or a test, y equals 4. So the answer would be 4, would be given. That's not our answer, though, because it's actually asking us to find the measure of the arc, okay? All right, so on this next one, we're going to apply congruent angles, arcs, and chords now. So it says the angle, our circle C is congruent to circle J. Now, what does that tell us? That tells us that corresponding things then have to be congruent, right? So it shows us also in this diagram that angle GCD, that arc with the tick, is congruent with angle NJM. Notice this, that these both have one arc, and they also have one tick on them. So that tells us that these angles are congruent. So what does that mean? That means that both the corresponding arcs, DG and NM, and these chords, DG and NM, are congruent. So I'm going to go ahead and mark this. This is obviously got to be congruent with this, right? Because if the angles are congruent, then the arcs are congruent, okay? So we're going to say that DG is equal to NM, okay? Or MN. Doesn't matter which way this time, okay? So, let me, my pen is all wound up, okay? So that means we're going to put this formula, 14t minus 26, and that's going to be equal to our 5t plus 1, okay? So I'm going to add 26 to both sides. So that's going to give us 27 over here, and then I'm going to subtract my 5t from both sides. That's gone from there. Minus 5t, that's gone from there. So that gives us 9t is equal to 27. So we're going to divide both sides by 9. So that means t is equal to 3, right? So once again, that would be one of your answer choices, not the answer though, is it? Okay, this time we're going to find the measure of NM, okay? And NM is going to be 5 times 3 plus 1. That's 16, right? Because that's 15 plus 1. So NM is equal to 16. Now, what should DG be equal to? The same thing, right? Okay, so we're going to do to check it, we're going to find DG as well. So we're going to do 14 times 3. That's 42 minus 26. 42 minus 26. Guess what that equals? 16. So it does check out. Okay, so remember, checking things is good because it makes sure that you get the answer right. All right, let's see if you guys can figure this one out. It says here that PT bisects angle RPS. What does the term bisect mean? Cuts it into 2 equal parts, right? So doesn't that tell us that RPT, this angle right here, is going to be congruent with that angle right there? It does. So what does that mean about our chords? Doesn't that then mean that chord RT is going to be congruent with chord ST? It does. You're right. Okay, so we're going to say RT is equal to ST. So that means 6x is equal to 20 minus 4x. Let's add 4x to both sides. So that gives us 10x equals 20. Then we're going to divide both sides by 10, right? So x is equal to 2. Once again, that would be one of your answer choices, but is it going to be the answer? Correct. No. Okay, so it's asking us for RT. So RT is going to be equal to 6 times 2, which is 12. And once again, we can check this, right? By finding what ST is, right? ST is going to be equal to 20 minus 4 times 2. Isn't that 20 minus 8? And isn't that also 12? And indeed, if those two measures are the same, then they are congruent, and that is the correct answer.